So, sorry. We didn't.
So on this one, would you like times the 2x over 6 by 4 and to get the bottom to be 24?
What I don't want to do is to get the bottom to be 24. So I'm going to say the magic trick is, and this isn't pretty, but I'm recording now because I think this will really benefit people. But if you have an equation with fractions, you multiply each term by the LCD and then all your fractions disappear. And how do you do it? The LCD in this case is a 24, and you need to put the LCD in each numerator, meaning multiply, put the 24 here. You put the 24 here, and you're acting like you're multiplying. Okay, this is critical. But if you do this, at first it's weird, and people need to get used to it. Some people say, I'm not gonna do it this way. I've never had to. I'm like, when you get to stuff like here and 7, 6, or complex fractions, you really need to be able to do this. So it's.
So you multiply the numerator by the LCD?
Yes, you put the LCD in each numerator.
Okay.
And again, it's weird to do it the first time, but once you do this a couple times, your life is so easy, and you need to embrace this. Hi, Kelsey. You actually came in at a really good spot. We've already done some 7-1 and 7-2, but this is, I don't remember. It's when you're solving an equation with fractions and they look worse now. You know, this is somewhere in chapter 7. But so we chose a basic one, and it started out as a 2/3 plus 5x over 12 equals 2x over 6 plus 7 over 24. I just made that up, but I'm just trying to show you guys how to get rid of these ugly fractions that everybody hates. So you're going to put the LCD, you can figure out what's the LCD, and then you put that in each numerator. And then you're going to say, hey, 24 times 2 is 48, divided by 3 is, I don't know, but 24 and 3 cancels into 8, and 8 times 2 is 16. You can say 24 times 2 is 48, 48 divided by 3 is 16. You're allowed a calculator. That's totally okay. You can say 24 times 5 is a big number, divided by 12 is something else. But why don't we just say 24 and 12 cancel into a 2, and 2 times 5x is 10x? See? And you say 24 times 2 is 48, divided by 6 is, I don't know, but 24 and 6 cancels into a 4, and 4 times 2 is 8. Again, if this gives you trouble, use a calculator. There's nothing wrong with that at all. If you don't, you know, some of you will be complicated. You'll say 24 times 7, and you would just have to know what it is. And then you turn around and divide it by 24. I'm going to say, hey, I'm going to cancel that 24 and that 24. And guess what? Is this not something manageable? You know, this is something where you could say, oh, I can definitely solve this. You know, it might be some weird fraction at the end, but you see how you got rid of the fractions in the beginning immediately. Now you need this concept here, over here. I'm going to do the blue. This is the problem we started working on. And maybe this is not until closer to the end of chapter 7, but still it's coming. So we might as well. So what do you have going on here? This is a lot going on. First of all, you have to find the LCD. In order to do so, this is part of, is it 7.2 or 7.3? 7.3, I think you start finding the LCD. But to find the LCD, the steps are factor each denominator completely. So if this is a little bit premature, that's okay, because next week we're going to have these word problems and they take a lot of time. So we're going to factor each denominator completely. So you look at these denominators. Do you see that m minus 2 is just m minus 2? Because you can't factor it. You know, m minus 2 is m minus 2. Then you have an m plus 2, m plus 2. And I'm going to separate them. And then the denominator here is m squared minus 4, which if you factor it, and I'm going to run out of room, is m plus 2 times m minus 2. Do you believe it? because remember when you FOIL, or a squared minus b squared is a plus b times a minus b. Right? Difference of squares, factors. Okay. So do you all agree that this is inside of here already, and this is inside of here already? I separate them with big fat marks here. You know, I do that on purpose. So that tells you that this is your LCD. It's the smallest thing they'll fit into. And Chase, we were talking about that 24. It's the smallest number they all fit into. Like if you found, and again, I like to show all the basics, but between 3, 12, 6, and 24. You see, if I asked you to factor them all, you would say, well, 3 is a 3, 12 is a 2 times 2 times 3, 6 is a 2 times 3, and 24 is a 2 times 2 times 2 times 3, 8 times 3 is 24. And then you would say, okay, I see this one already has, these 2 fit into here, this one fits into here, that 3 fits into here, that 3 fits into here. That's why you need to look at them separately. And that 3 fits into here. So your list, this is pre-algebra material. Your list would be, I see 2 2s, I see 1 2, I see 3 2s, I see the 2, I see it twice, I see it once, I see it 3 times. What's the most I saw it? I saw it 3 times. And then you say, I see a 3 once, I see it once, I see it once, I see it once. So you list it once. And then this product here is your LCD. That's basic math. This here, I see an m minus 2 once, I see it never, I see it once, I list it once. I see an m plus 2 once, I see it never, I see it once, I list it once. So if I were going to find my LCD, you know, for the list, I have an m minus 2 and an m plus 2, that's it. You don't want to list every single one. But this fits into here and this fits into here. Just like that 3 fits into 24 and that 2 fits into 24 and that 2 fits into 24, etc. So then you do what you did over here. You put that LCD in each numerator, and this is looks really ugly, but it's super easy if you understand that concept. You're going to put it m plus 2, m minus 2. That is your LCD. M plus 2, m minus 2. That is your LCD. M plus 2, m minus 2. That is your LCD. So again, you put it in each numerator. This is still the same as when you're doing basic math. This needs to be practiced once, and then you can, I believe that after that it'll flow. Now, maybe I should have taken this piece here and factored the denominator first so that you could tell that it's right there. Don't you agree that the m squared minus 4 is the m plus 2 times m minus 2? So here we have upstairs, downstairs. We have an m minus 2 and an m minus 2, and they cancel. So what's left then? Now you have a 3 and an m plus 2 left. Maybe I miscommunicated, but okay, so I know I switch the time all the time. Minus. Now what happens here? You cancel this one and this one, you see? And then what's left? 5 times m minus 2 equals. Now m squared minus 4 is really m plus 2 and m minus 2, you see? So you could replace that with that, and then you could say, oh, upstairs, downstairs, upstairs, downstairs, regardless, they're gonna cancel. So what's left? Only a 6. Now this is manageable. Just like this here was manageable, now this is manageable. Because if you see a bunch of fractions, you run for the hills. But if I show you how to do this trick and make the fractions disappear, then you get something that's manageable, and all of you can solve this now. You see? Because now you just say, oh, okay, 3m plus 6 minus 5m plus 10. Don't forget to distribute the negative, right? Equals 6. And then you have combine like terms. You know, combine like terms. And then you get rid of that 16. So you get a negative 2m is negative 10. M is 5. And then before I look at this as a final answer, I need to ask a question, and this is something that happened in 7-1, did it? And you guys aren't quite there. It just depends on what class you're in. Kelsey, I can't remember. Are you in a 112 or in a 110?
I think I'm in the 112.
Okay, I think all of you are. So that's good, because I think you have 7-1 and 7-2 due this week, right? And didn't it talk about the domain in the 7-1?
Yes.
Okay, so this is later in chapter 7, where you know how you always do like add, subtract, multiply, divide, add, subtract, multiply, divide. You know, pretty much every chapter you add, subtract, multiply, divide, and then you solve. Here you solve. You have to also learn how to solve before you do word problems, but this is probably 7-5 or 7-6. I can't remember. So this is a little beyond where you're at right now. But in 7-1, we talked about the domain, and it's all about what can X be? What can X be? And I don't remember covering this with you guys yet, but this is a good time to do it. Or M in this case. You know, what you're really asking is, and I usually try to show a graph, and now I'm out of room, this is a mess. But you really have to say, what can X not be? Or what can M not be? Because you're actually solving now. And if you solve, let's say you get down here, and let's say, I'm just making this up now, you know, but this isn't true. But what if I said M is 2? If I said M is 2, you have to go back to the original and say, what if M were 2? 2 minus 2 is 0, totally illegal. You see, M can't be 2 because it causes an undefined. So this is something we need to cover here. M also can't be what? What else can M not be if you're looking the original? Anything that causes a 0 in the denominator. You know, so what can M not be? Anything that causes, not a 0 itself, but anything that causes a 0 in the denominator, because guess what? Isn't that then undefined? And undefined is not allowed. You see? So this is a total disaster, this whole page.
It could like not also be negative too.
Very good. I wanted you to come up with that. Excellent. Because if you say, oh, if you go to the end, and this will happen sometimes where you're working the problem, and I forget, I do this every semester. You need to list your restrictions. This is called list restrictions. And this is step 1 in the equations that have fractions, because if you do M is negative 2 and at the end negative 2 plus 2 is 0, you know, if you found that, if here you had solved and you found M is negative 2, you would have to throw that in the trash, because you would have to say that is not an option, there's no solution, because you cannot have M is negative 2 because it causes a 0 in the denominator. And then here, can you tell what M can't be? Well, look at this one. In factored form, it's really just an m plus 2 and an m minus 2. So if either one of these causes, you know, if you have 0 plus 2 or negative 2 plus 2 is 0, or if this one's a 0, it causes a denominator of 0. So that's covered right here already. Did that probably make it worse? It might have been better to hold off with this until next week. But Markeisha's ahead, I know, and I don't know, you know. Chase and I worked for the first 20-some minutes, we worked on 7.1 and 7.2. Or so we actually worked on 7.2, multiplying and dividing rational expressions, because we did start at 7. I know I changed time a lot, but it depends on what's going on at my house. So I try to make it work. So you have to just, do you want me to work some of those again? Or I can find some that Chase and I haven't done, but that are on this next, this is like a test. Hang on, let me clean this up, what a mess. This is like an actual, similar to a test or something. Okay, so here's a perfect one to look at real quick. You see this one here, it looks different, but it's actually easier. What happened, the student complained to me because on the review we had something like this, you know, like this. And then on the test, it was something just like this. And I'm like, well, isn't this easier? So since we did work on that, let's do another one. Let's do this one. Whoops. Just to make sure you got it. So you see how you see an equation with fractions. So then you say, oh, I need to make the fractions disappear. But the first thing you should probably do is list your restrictions, because, you know, that just got me in trouble on the last one. So step 1, what can x not be? X cannot be so you look at the denominators and say, what would cause a 0 in the denominator?
Zero.
Right, and in this case, it's the only thing that'll cause a 0. You know, because this is 1 over 1. So if x is 0, it causes undefined here. If x is 0, it causes an undefined here. So x cannot be 0. Okay, step 2. We're going to solve. When we solve, we find the LCD. So what is the LCD? In this case, also easier than on the last one, right? Because you have so this is what you do. You factor each denominator completely. You have an x. And then you have separate an x squared, which is an x times x. And then you say list. I see an x once, I see it twice. The most I saw it was twice. So this is my LCD. It's the smallest number they both fit into. You see how x squared doesn't fit into an x, but an x fits into an x squared. So now you're going to use the magic trick. Or in the book, it'll show it, it's the same thing. They will show the same thing. Sometimes they do this. They show it like this, and they put an x squared here. I don't like doing that. I like showing each individual piece. So we're going to do the magic trick. Or make fractions disappear. So what do? You put the LCD in each numerator. This will help you not cancel the wrong way. And then cancel commons, right? And then your fractions will automatically disappear. It has to happen. So we have 1 plus 1 over x equals 6 over x squared. So then you're going to say, I have an LCD. This is technically the numerator, so I'm going to put my x squared here, here, and here. Yes? Do not try to make all the denominators x squared. Students get hung up on that. Yes, when you're adding and subtracting fractions, you have to, but we're not adding and subtracting fractions, we're solving. Yes, so this is a little confusing because in 7.4 you have no choice. I think it's 7.4 where you're adding and subtracting. You have no choice. You can't do this. You cannot, a magic trick will not work unless it's an equation. Okay, that's why I wrote that down, like if equation. That only works if it's an equation, I'm telling you. Do not try this on regular adding and subtracting, it won't work. Okay. So then what happens? X squared times 1 is x squared. X squared over x is x. And cancel, cancel. Right? And then how do you solve quadratic? We've done this before. It's in the old chapter, right? So we have x squared plus x minus 6 is 0 because that's standard form. I don't want to write all that down again, but that's the steps from back when. You know, you just solve. And then you have open, close, open, close. This is a gift, right? This is a gift. So people that complain about this problem on the test, this is a gift. Because you didn't have to go over the top. You don't have to do anything weird. X, X. What's my product? -6. What's my sum? +1. -3, +2. +3, -2. Yes? So I had the wrong one at first. 3 times -2 is -6 true. 3 minus 2 is +1 true. Double check your work. And then you solve each one of these individually. So I'm out of room. So you get x is -3 or x is 2. And then you check it against your restriction. They're allowed. The only thing that's not allowed is a 0. So your final answer in solution set is -3, 2. How's this? Doable?
Very helpful.
Oh, thank you.
So, question for you.
Yes.
So whenever it says solve the equation, I came in a little bit late.
Yes.
So I see that you did like the magic trick portion. Is that
Yes.
only if there's an equal sign?
Yes, so this
Or-
is why I said that here again. The magic trick will not work if you're just adding or subtracting fractions. It only
Okay.
works if it's an equation.
Okay.
So that's critical.
you.
Yes, good question. It's critical. If you later on, or in 7.4, I think you're adding and subtracting a bunch of stuff, you're going to have to make the denominators the same. You find the LCD, but then you work it differently.
Right. Okay.
Yep. So 7.4, I'm happy to work some too. What I did was, before Chase and I started at 7, I grabbed some 7.1 and 7.2 stuff, or mainly 7.2 stuff. And then I had this open. This is the chapter 6 and 7 test, okay, or exam review.
Okay.
So this is where I kind of grabbed stuff off of there. There might be some, and then the factoring, I think we've done this before, you know, that we did, but we didn't
Yeah.
do, factor the binomial completely. We did this here, didn't we? Like where you factor a difference of squares here. Difference
Yes,
sum
I believe so.
squared, so it was continued. That was that one you asked about that last time, you know, where we had x squared plus 9, x squared minus 9, and then we said, okay, this is a sum of squares, we leave it alone, but this is a difference of squares, so we continue with this one and split it again,
Yes.
you know, and then we did this before. Okay, so, and then there's the domain. Okay, so this was some test that, and I was making some notes for the student last semester or the year before, I can't remember, but find the domain. So if we're looking for the domain, 7.1, I mean, Chase, you were asking about 7.2, so I think you've done this before, but do I need to go over this or should I go over this? But, you know, this is the what can X be? Or more importantly, what can't X be? Meaning you have to get rid of anything that causes a 0 in the denominator. So what you do is you set it equal to 0, which is kind of counterintuitive because you're saying, I'm telling you the denominator can't be 0, but you have to set it equal to 0 and solve or factor it. -6, -8. And then you have x is 6 and x is 8. And then you definitely, you're actually going to come over here and say x cannot be 6 or 8. Because both of those, if you plug them into the original, it's going to cause a 0, and that is not allowed. Is that okay? Like, I'm going kind of fast, but. So the book or the computer will say x is real, x cannot be 6 or 8 or something like that. You know, that's what the book will say when you're looking for the domain. Yell if it doesn't make sense. Find the domain. So what is the domain here? We've done this. We just did something very similar, right? Oh, you see how here I told the young lady that she had chosen to, she answered it using a different notation. She used an interval notation, which is actually kind of cool because she's telling me that anything from -infinity to 2, but not including 2 is an option. And, you know, she went on and on. I mean, this is good stuff. It's actually true. But this is here is where you would just say the domain is x such that x is real, x cannot be -2, 2. So this is just like that one. This is a difference of squares. So you factor that, set it equal to 0, and exclude those values. And then I was telling Chase, when you have a numerator denominator, all you do is factor, factor, cancel, cancel. So numerator, denominator, factor, factor, cancel, cancel. So you just, you know, and people struggle with this. Like, people try to factor this one like a trinomial. This is not a trinomial. And why would you ask that? First of all, you're supposed to say, hey, she says factor, I say greatest common factor. They both have an x, x times x plus 9. You see what I'm saying? You would not try to factor this like a trinomial. You don't look at how many terms. You always say GCF, is there GCF? Once you pull the GCF, then, sorry, I'm looking outside and my cat is crawling up. Hey, Greg, come here for a minute, sorry. The cat is up the whole screen door to the top.
Oh my God.
Don't let the dogs out. Sorry, I have some foster dogs and they might want to kill my cat. Distracting, this is not work related. Okay, simplify, numerator, denominator, factor, factor, cancel, cancel. So this is all pretty basic. Find the function value. Here, if it asks you to find the function value, f of -3, all you do is plug it in. So those are gifts. What do you want to be careful with real quick? This is the main mistake people make. They don't do the parentheses, or they don't understand what happens here. I'm just looking at the denominator now. What is -3 quantity squared?
Nine.
Right. This is the main mistake that usually happens. And then this is a -21 plus 7, etc. I'm not going to work this. This is basic math. You can use a calculator even. Calculator won't help you if you don't use parentheses. So pretty much you just simplify it down. There's where you're multiplying. So when you multiply, you go across and you factor the heck out of it. That's what we talked about before. I didn't even record earlier because it was just Chase and I, and I've been outside all day and you can tell. Okay, so multiplication, factor, factor, cancel, cancel. Now this is not so straightforward, is it? If maybe we should do something like this because it's a little bit less straightforward. Yes, no, let me know if you don't want to do it, or I know we see the answer already. I hate that. But pretty much you have multiplication. So I'm going to say go across, but do not FOIL or distribute, and just factor the heck out of it. Now this, you might have to do it off to the side. This is not a simple trinomial, you know, and there's no common factor, so you're going to go over the top. You see it? So this is 6x squared plus 31x plus 5. Keep that, and then you're going to do that over the top thing is 30 and 31. It's not bad. It's 30 times 1, you see. That's not bad at all. But you got to know how to factor. I'm going to do plus 1x plus 30x. That way I have some to take out here. You don't have to do it that way. But this is just that, you know, you split the middle term and you double bubble. X times 6x plus 1 plus 5 times 6x plus 1. So sometimes you have to factor off to the side. Or some of you actually can take this and immediately go to this by trial and error. And since they're both positive, it's not hard, that one. But I always show it this way because everybody can do it. And then the denominator, oh, you pull the x. And then you have x squared minus 25. What is this? Difference of squares? X plus 5, x minus 5. How to, so you go across, you factor the heck out of it, and then you say factor, factor, cancel, 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 and then you have 5 over x left. Very nice and clean. If nothing cancels, you're doing something wrong. But sometimes not everything cancels. And then you have your division. I think we did one like this. Right, Chase, you and I did one like this, but it's the same thing. You keep the first thing, you change this to multiplication, you flip the second one, and then you do exactly what we just did. But when you're dividing, you keep, change, flip, just like in the old rules. Do I need to go over them, or how are we doing? And you guys are all 112 people. 110 people need more review, you know, because they have more gaps. And we fixed them in this class. But you guys are all 112ers. They don't need help, 110ers. They know exactly what's going on. This is adding and subtracting. That is 7, 4. So do we want to do that next week, or how we're feeling? I mean, we've done this before, so I'm okay. Go ahead, Makisha.
I was gonna say you can work that one, because I think I struggle with these.
Okay, so let me work a couple. I mean, don't feel like you have to stay. There was one day, you guys all, because you're my regulars, there was one day a young lady was here and I did not get her name, and I kept looking at my roster. I'm like, I don't know. And it's harder with the face because it's an online class. There's one person that I didn't give credit to, and I'm trying to figure out who it is. She never yelled at me. Arg. I didn't want to ask class, you know. Anyway, so here you're subtracting. If you're adding or subtracting, you need an LCD, yes? So
yes.
In this case, this is a gift, because this one here, maybe she'll watch this video and then she'll contact me and say, I did not get credit. Okay, so what you do here is you say, hey, I already have a common denominator. This is a gift. So I would just go across and put them over the common denominator. Right? Because if you have a 2/3 plus a 5/3, don't you just go across?
Yeah.
This is basic math. You know, you got to know the basic rules or you're going to struggle here. So if the denominators are the same, you go across. Okay. So then you say, okay, now I have a numerator, denominator, and I'm going to factor, factor, cancel, cancel. What's kind of funny here is some people do this and they did all this good work and then they cancel, and they cancel this. And I'm like, hello, you can't cancel unless you have multiplication. Yes? So we're going to factor 4 times m minus 6 over m minus 6. Cancel, cancel.
Okay. I think that's where I'd make the mistake too, is because since it's over something, it looks like division, which is basically multiplication.
Right.
So seeing the line or having something over it makes it look like you can cancel like you did the first time.
Mm-hmm. But see, and that's the thing, you always have to think factor, factor, cancel, cancel. If you have multiplication, you can cancel.
Okay.
So, let me work this one here. This is adding and subtracting fractions. I need an LCD. So here you have to do a little bit of work. This is why I kind of want to, I need to move down a little bit. So I have around. So I'm going to go ahead and clear my screen again. So LCD. So you factor each denominator completely. So let's look at these separately. You have an x plus 2 in factored form. It looks like this because there's nothing you can do with it. Now, how can you factor 9x plus 18?
Yes, you can take out a 9.
So you got to know how to factor. And I always say that if you can't factor, you're toast. I mean, it really is truly, because everything chapter 6 and 7 is factor, 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 you know. So anyway, so what is your LCD? So this is when you list the factors. I see, and you could break this into 3 times 3, but let's not. I see a 9 once, I see it never, I listed once. The most I saw it was once. I see an x plus 2 once, I see it once. I only listed once because the most I saw it when I looked at them separately was once. So this is my LCD. So
Okay.
I'm going to do steps here. When they get more involved, you need to do more. This is the LCD piece. That's separate. That's just, I think you have one section where you just do LCDs. Okay, so to add or subtract, it's best if you rewrite without doing anything, without changing anything. Rewrite each fraction or rational expression, RE, with the denominator factored. Only the denominator. Do not try to factor denominator in factored form. This is not pretty. So what you don't want to do is try to do sum to the numerator right now. It's different than when you're multiplying and dividing. Okay, so rewrite it with the denominator factor. This will help you later not accidentally do something wrong. Okay, so this is, I changed absolutely nothing. Now, if this were an equation, I would use the magic trick and I would say, hey, I'm going to put a 9x plus 2 in each numerator, but that doesn't help me here because I'm not allowed to use the magic trick. Okay, no magic trick. Not if it's not an equation. So what do? I need to create a common denominator for both. Since I already know this thing is my LCD, wouldn't I then just leave this thing alone? But here I say I need, and this is how I teach it in class. I say don't worry about anything here. Just say, what is my LCD and what does it need to look like? This is what it needs to look like. And then you say, well, what did I do from here to here? I multiplied times 9. Whatever I do here, I do here. Right?
Okay.
This is like the basic math piece. So then you get an 18. And then you're allowed to go across. So this is a pretty basic one. I'm kind of hoping we'll get one more that's a little more involved. But 18 plus 3 is what, 21 over 9 times x plus 2. So you rewrite each with denominator in factored form. That's step 1. Step 2, find the LCD if you need steps. So we found the LCD. Step 3, rewrite each RE with that LCD. You know, that's what we did here. That's essentially what we did right there. And then we're going to add and subtract. And then you factor, factor, cancel, cancel. You see? Now here it's pretty basic, 21 and 9, you're going to cancel the 3's. But, if this were, sometimes these things are trinomials. So this is not, they're not always as friendly. So sometimes these are trinomials, or this turns into a trinomial. You need to factor and cancel. So if we're going to go back to basics and keep it basic, we could say, well, 21 is 3 times 7, 3 times 3, x plus 2, cancel, cancel. So this is a final answer, or this is a final answer. And Chase and I talked a little bit about what do they want for final answers. It depends on, the computer should take either, because one is in factored form and one is in distributed form.
Oh, goodness. Okay.
What's the matter? What'd I do?
No, you did fine, but for whatever reason, my brain, like you were doing it, and I'm like, okay, this makes sense.
Yeah.
But for whatever reason, my brain looked at whenever you rewrote it and basically added the 9 to the denominator on the left side,
Yes.
my mind instantly thought to cross out the 3 and the 9.
Oh yeah, that's
Instantly.
illegal.
It's illegal.
So in the classroom, I have a lot of fun with this. I'm like breaking the law. But it's just illegal, because what you have to do is, this is why steps are so important. You rewrite each one with that LCD, and then you have to add and subtract, because if you're multiplying, you do that. But this is adding and subtracting, so everything changes. We have to go across, maybe I need to put that step in. You're not alone. This is very confusing to a lot of people, but this is like if you have A over B plus C over B is A plus C over B, basic B, you can't fiddle and cancel around here at that point. You need to go across first, then cancel that 3 that's in here. And it's just a coincidence that, if this had been a 17, or, well, if this had been something else, if this had been a 1, well, sometimes it just doesn't. This is a coincidence that this 3 fits in here so nicely as a factor as well.
Okay, I got you.
But you really probably need to go from here to 18 plus 3 over 9 times x plus 2. Completely illegal to cancel these two.
Okay, now that makes more sense. Okay.
Yeah. Only if you have multiplication, that is critical. Yes? Now
Yes.
you create, and now here you're creating multiplication. Then it's legal to cancel that 3 and that 3.
Okay.
Yeah. Good questions. But yes, that's exactly the kind of things, where people are like, oh yeah, everything she's doing makes so much sense. And then they're on their own, and then these little things happen. And it'll throw off your whole problem. I'm hoping there's another one. Nope, nothing majorly good here. But we can use that one. I'm going to write it to the top. I don't like being influenced by their work. But one more? Or do you have one that you want me to work? Because I'm happy to do it.
I have a question. I did do I got the answer eventually, but I wanted to see if there was an easier way to achieve this answer.
Okay, hang on a minute. So you have a problem I can work? Oh,
Yes.
okay, hang on. Let me make some room.
Okay, no problem.
Okay, perfect. I'm all ears. I love it when you guys bring problems, because I hate bringing my own.
Okay, so it was 25x squared minus 30x plus 36 all over 125x squared plus 216.
One 25x squared or
Yes,
x cubed?
x squared. Let me double check. X squared. Yes, x squared. Oh, wait. No, I think you're right. It was x cubed.
Okay.
Yeah, 125x cubed.
Okay. So now here, this is a wonderful problem because I used to take this numerator and try to factor it and I'd get so frustrated. Let's look at this numerator for a minute. Let's play with this for a minute. Okay, I say factor, you say greatest common factor, there isn't one. Then you say, what is it? Oh, is it maybe, is it a trinomial that's simple? No, it's an over the top. 25 times 36 is hideous, you know, huge. So we say, hey, maybe it's special. You know, this is kind of how I worked them last time where I analyze, you know, if it's special, A would be, this would be something squared, and this would be something squared, you see?
Yeah.
But if it's special, so if it's that 5x, this is a minus and a 6 squared, this is not true, okay? But if it were, this piece here, not worried about a sign, would be a 2ab. Now look at this, a times b is 30x. This is a 30, it needs to be a 60 if it was factorable, the way I just did it, you know. And then also check this by FOIL, you know, and you found this out already, Markeisha, because you got frustrated by it, and I'll show you, that's exactly what happens. But if you FOIL this, you get a minus 30x and minus another 30x, you get that 60. So this is not factorable.
Okay.
Or it's definitely not a special one like this. You can still try to do the over the top, but I can tell you it's not going to work. Now, then you say, well, oh my goodness, that's annoying. Did you guys do the cubes? This is a formula, a cubed plus b cubed, and what you do, and I won't show them, like sometimes I show this in great detail, but you have a binomial and a trinomial. And what you do is you put one, you see how you have 3 factors of A, and you put one of them here. And then you put the remaining 2 here. And then you have 3 factors of B, and you put one of them here, and you put the remaining 2 here. So A times A squared is A cubed, true, and B times B squared is B cubed, true. And then what you do is in the middle, you just simply put AB. You guys are allowed these, I'm giving them to you in the test, okay? So you don't need to worry about this. But I used to not do that. We used to make people memorize them. So then I would say, then you know, I swim in my pond and then I get in the shower and I use soap, because that's a good idea, you know, SOAP. Okay, so what we do is we use soap for this, and what that means is S for same. So this is the same sign. And then this one here is opposite. So that's that SO. Opposite of plus is minus, and then this is always plus or always positive. So AP, you know, so you can memorize, that helps you memorize SOAP. Anyway, so the way we can factor this denominator is, so in this case, it was really annoying for you because you struggled through the numerator. I've done that before.
Yes.
But then that's why I said, is that a cube? Because then I say, oh, okay, I have a binomial and a trinomial. Is this something cubed? Yes, that something is 5x. Is this something cubed? Yes, that something is a 6. And then you say, okay, there's an A here. And then there's an A squared here, which 5x quantity squared is 25x squared. Then there's a B here. And there's a B squared here. 6 squared is 36. This is AB. So I always label my A and my B so I know what's going on. 6 times 5x is 30x. And then we use SOAP, same, opposite, always plus, and guess what? That's the numerator.
Oh my. Okay, so yeah, that made it a lot easier.
Yeah, so I mean, if you have that formula, you just decide what's A, what's B, you know, which one cubed, and you can use your, if you need to learn how to use your calculator, folks, because pretty soon in chapter 10 and 11, we're going to do radicals. And even I need a calculator.
Oh, okay.
Really, I don't use it. There's one word problem where you have a huge numbers, but I don't use calculator hardly at all. But for the radicals, sometimes I need it because I don't know what the fifth root of such and such is, you know, for example. But anyway, you could, if you know your calculator, you could do a cube root of 216 and it's going to shoot out a 6, you know, but you got to play with that. The nice lady, Julie Crawshaw, she does the tutoring. That I don't know if lots of people are taking her up on that, but I mean, I have it, I sent an announcement, you know, so I'm hoping people contact her, but you can just pop in her room, I think. If you say, hey, sometimes I just want to pop in your room, she's in there from so-and-so to so-and-so every day. And you could just pop in there and say, hey, this is the calculator I'm using, where's mine? I have one somewhere. You know, I have this thing and I can't figure out how to do something, and she can probably help you. So. Anyway, that
All
was
right,
me.
thank you.
You're welcome.
'Cause, yeah, that numerator, it was throwing me.
I don't usually, and that's the thing. I got so hung up on that one time, and then I did the denominator and smacked myself. It was like, oh, in this case, you're better off doing the denominator first. Oh yeah, I didn't go to the end. Here, let's finish. So this is really that cancel, cancel, final answer. Just remember
So it's
that
one.
piece is in the denominator, so it has to stay in the denominator,
Okay.
right?
All right, thank you so much.
You're welcome. Okay, anything else I can torture you with on a Wednesday evening? And do you want me to work this one real quick? It's just because it looks so basic, but I want to make sure we get the right denominator. So last one,
Yes.
is that okay?
Yes.
Okay. You are adding or subtracting. So we're not going to use magic trick. You have fractions you have to deal with. Okay, step one, rewrite, and you also don't have to list restrictions. Do you see this here? When do we list restrictions? When we solve. When do we solve? When we have an equation. Okay, so you don't have to worry about restrictions here. But could you rewrite the denominator in factored form? Yes? And x minus 8 is just x minus 8, you see? And then you find your LCD. And your LCD, you have a 7x and you have an x minus 8. Do you see how this x is not going to cover that x? This is kind of important. And so to list them, say that again?
I was saying, is it because the x is part of another number, or and it's being
because
like
this is factored, you see?
Okay.
This isn't factorable. You see, x minus 8, if I tell you to factor that, you say I can't. It's just x minus 8. So it's a binomial that goes together. You can't just take a piece away. So when I ask you to list the factors, you see you're listing each factor the most you see it. I see a 7 once, I see it never. I list it once. I see an x as a factor once. I see it never as a factor by itself. So you have to list it. And then I see an x minus 8 and I see no x minus 8, but I see an x minus 8 once. I have to list it. And this is the important part, that's my LCD.
Okay.
So you can't just grab one x, you need them both because this one is a piece of that factor. So then you, what did we do earlier? I said, hey, now you're gonna rewrite each one, you're gonna write it with the denominator. So I want you to keep the numerator blank. That's your best, that's really best if you do that. And you say, I'm gonna put my denominator the way it needs to be in factored form, the LCD. This is actually a really good one. Now I'm glad I did it because it looked so basic at first, but then it gets more involved. But so this is what you want to do. You want to keep them blank at first. You just want to say, hey, what does my denominator look like? Because this has to happen for you to add them. And then you say, well, what happened from here to here, from 7x to 7x times x minus 8? Do you see how it's missing that piece? And whatever you do downstairs, you have to do upstairs. You see it?
Mm-hmm.
So then you come back in and say, oh, my numerator is 6 times x minus 8. Now,
6x
I'm going to go ahead and write it like this for a second, and you guys will have to bear with me. I'm doing this on purpose. Now, the next one, you're going to say, hey, what happened from here to here? Do you see how you're not going to do the same thing? What's missing?
7x.
You see, this is missing. And this helps me see it from here to here. It really helps me. So times 7x. So then you have 4 times 7x. You can make it a 28x, right? Why am I not keeping it like 4 times 7x? I can, but this is where that mistake happens again. You know, people do all, hang on. I'm going to undo. Okay. So this is 4 times 7x. People do all this wonderful work. You know, this is already involved, takes time. And then they do this. Do not write this down. They do this, and I'm like, what did that just do for you? It brought you right back to here. Do you see what I'm saying? Do not do that. Why did they want to do it? Because they want to factor and cancel everything, but this is a plus. You can't do that. So I'm going to erase everything blue, or hopefully all the red will go away. So please don't. Why can you not cancel? Because this is a plus. So what do? You have to go across. You have a common denominator now, yes? And my denominator is 7x times x minus 8. There's no need for me to distribute through. But the numerator, I need to go ahead and distribute through. Otherwise, I can't combine these things. You see how there's going to be like terms to combine. 6x minus 48 plus 28x, yes? So do not cancel this stuff.
Okay.
And then 6x plus 28x combines. And now you have a numerator denominator, and now you would factor and cancel if possible. You see? I have no clue right now in my mind. I know there's a 2 in both of those. So now I need to factor and cancel. The denominator is already factored. That's why I didn't want to distribute, because that just makes it messy. Can I factor this? There's a 34, yeah. There's a 2.
17x. 24.
Is there anything else? No, 17's prime.
Yeah.
And then you have a 7x times x minus 8. Do you see how this did not help me?
Mm-hmm.
This is okay as a final answer. I like this best because it's completely factored, and I know it proves to me that I can't cancel anything. This is okay as a final answer. And one other thing that's okay for a final answer is you distributing this if you wanted to. They're all okay for final answer. This one I like the least, because then I think, what if I could have done, you know, it makes me think I want to simplify. So this is my favorite.
Okay.
But it doesn't matter. Computer should take them all, because they are simplified because nothing cancels. Let me see what their answer was. So I'm going to leave my writing as stays up there. Okay, so this is what the computer wanted. The numerator is not factored, the denominator is factored. That's kind of inconsistent in my opinion. So that's why I like this one the best. So super fun on a Wednesday night. So what are we doing now? I mean, what are we doing next time? Or do you want to keep doing this stuff, or do you like only 3 people show up now? Maybe the time is bad, you know, I thought, but you know, we said we want 1 in the morning, 1 in the evening. Anyway, go ahead.
I like any of the classes. Like I said, I'm available whenever. And I definitely appreciate this time because I usually circle my homework questions. If I haven't sent them to you, like if it's not in dire need, I'll
Right.
circle them to ask you to work them on here.
Okay. And if not, if it's something you need, like, okay, so if we have something due Saturday night or Sunday night, we can meet like this on a Saturday night. I mean, it doesn't bother me. You know, I just have to make it work with my schedule. Dinner has to be cooked and child has to be taken care of, you know, so. Anyway, I appreciate you all coming. And then tell me what day you'd like next week so that I can try to accommodate. It's almost 4th of July, like, not that it matters this year. Nobody does anything. I'll write it down. What day's good?
Oh, yeah. It's on the- I'm good any day. Whenever everybody else is good.
Monday morning at 8?
That's
I think,
fine.
Kelsey, you work days, don't you?
Yeah, I'm only available in the evenings. So anytime in the evening after 4:30, I'm open, or I'm free on weekends as well.
Okay, so let me look at the schedule. You know, if people didn't mind, I know people don't like that though on the weekend, but if we'd almost be better off because then everybody can attend, you know, everybody who wants to. But we'll probably do an 8 o'clock Monday, and then we'll probably do like, I don't know. But we might do sometime at 4:30 to 5:30 or something. I can still get dinner on the table after, you know, it just depends on what's going on around here. Okay, thank you for coming.
Thank you.
Thank
Because I
you.
keep bringing stuff and then I'm like, oh, we've done this before, but we need to definitely, next week, we need to work the word problems. The distance rate times time, so maybe earlier in the week, we're gonna go ahead and meet in the evening. That way Kelsey can show up.
Okay.
Thank you. I appreciate it.
No, I appreciate you coming. I don't need to make it, like, there are a bunch of people said 8 in the morning, but they never show up. The people that said 8 in the morning don't show up, you know, so let's make it sure that the folks that want to see it can see it. So thank you. We'll figure it out.
All right. Perfect. Have a good night.
You too. Thank you.
Thank you.